All right, this is the last section out of this chapter, 8.3F. This is for 7th grade math, unbiased and biased samples. And I can predict the actions of a larger group by using a sample. So this is actually very similar to 8.3E. It just kind of comes off of it. So we're talking about predicting the actions of a larger group by using a sample, but we're also talking about making sure we have good samples, and that's where the unbiased and biased comes in. So samples, when you're looking at a smaller group to represent a population, they can be biased or unbiased, and as much as possible, when you're doing your survey, you want it to be unbiased as much as possible. So unbiased means that the sample chosen would accurately represent an entire population. And there you can get really into the different types of samples, and there's all kinds of different types, but we have a couple here. A simple random sample means people are chosen randomly. So for example, if I'm drawing names out of a bag, if I put your names in, use the note cards that we made at the beginning of the year, put them in a bag and draw them out, that would be random. A systematic random sample would be that you're selected according to a specific time or item interval. So maybe if I wanted to do a survey, maybe I would ask every third student that arrived in the morning. And so it'd be systematic in that I'm doing every third, but it would also be random because I don't know who's showing up when. Biased means that one or more parts of a population are favored over others. So if I wanted to make a prediction about, I think in the last section we talked about how many text messages that middle schoolers send. If I only asked 8th grade, that could be biased. I could get results that are biased because maybe 8th graders send more text than maybe a 6th grader would. Maybe they have more access to phones. Same idea, like if I asked 5th graders, how many texts do you send? And I want it to apply to the whole building. Maybe not as many 5th graders even have access to phones to be able to text. So those results then would be skewed or biased. If you think of maybe when you're, if your parents get asked like who they're voting for an election, if somebody is standing outside the Democratic National Convention and asking people who are you going to vote for as they're going in and out, well, if they're at an event for Democrats, most of them are going to be voting Democrats. So those results then would be biased. So you have to be very careful about that, and you have to be very conscious of it. So some of the things that are biased are convenience. So the sample consists of people easily accessed. So when we were talking about the 5th graders, maybe it's really easy for me just to go up to their room and ask them real quick, raise your hand of how many texts that you do. A voluntary response, a sample involves only those who want to participate in the sampling. So maybe some people don't want to participate, but usually the people that have strong feelings, those are the ones that will answer. So sometimes that can give you biased results also. And you always have to question those. Are they good results? How much can you trust them? And even things like in the news a lot lately, because of all the COVID testing and the possibilities of different groups getting vaccinated now, there's depending on who you're asking, would you get vaccinated or not, or would you do this and that? You have to look at who are they asking. So whenever you see in the news, in the media, social media, results of any surveys, you should be thinking to yourself, who did they ask? How many people did they ask? What was the question? So those are the things that we want to consider. All right, so for our example, a 7th grade homeroom was surveyed to determine how many tech students at St. Mary's Middle School sent each day. So the population would be the middle school, the students. So I'm going to put St. Mary's, I'm going to abbreviate here, middle school students. The sample is 7th grade. And maybe the person who's asking is a 7th grade homeroom teacher. So it might be biased because of convenience, because maybe it's convenient for that teacher to ask the 7th grade homeroom. Convenient. So you have to be careful, but if it's just, say, Mr. Cubic coming in and he wants a representative, then it could be unbiased. So you have to look at all factors. So if it's just somebody else coming in and asking, you could say it's unbiased because it's random. Maybe he's randomly picking the 7th grade. Or maybe he's randomly picking just certain students from the 7th grade homeroom. So you have to be careful. You got to get all the details. And so a lot of these, it's really just how you justify it. All right, 7th grade homeroom. We put all students in the school. Oh, we wrote that. 7th grade homeroom was surveyed. And we had talked about that it's biased. We talked about if it could be biased or unbiased. And probably in the end, it would end up to be biased because maybe that one class of 7th graders doesn't accurately represent all the students in the school. It could also be, because we had talked about convenience, you could also say that it's not random. If you're doing everybody in that 7th grade homeroom, that's not random, unless you just pick them, that homeroom, randomly out of all the other ones. But more than likely, you had it planned that you're going to work with that class. All right, for example, to track migration patterns of a particular species of a bird, scientists randomly tag, release, and track 50 birds of that species. So the population would be the species of the bird, and those do look like Canadian geese. Not an expert, but that's what they look like. The sample is the 50 birds that we tagged. It's going to be unbiased because the birds that we tagged were randomly selected. We're just trying to get a handful of the birds to be able to track. And a lot of times these types of surveys, the information that we're getting when you're tagging different populations of animals, they would be unbiased. All right, so for our example here, you want to estimate the number of 7th grade students that walk home right after school in the springtime. Which sample is unbiased? If you ask 3 7th grade students randomly selected in the hallway before homeroom, let me see if it's written here. It's biased because you're only asking 3 students. That's really small to get an accurate conclusion. So that's a little bit too small. If you're asking members of the track team, that could be biased because they stay after school anyway. Let's say they have a track team here. You're staying after school anyway, and so they're not going to be leaving right after school. Every fifth, seventh grader walking down the sidewalk after school. And it seems like it would be unbiased because you're asking every fifth and it would be random. But they're walking down the sidewalk after school, so they're already walking home when you're asking them the question. The last one, every fifth student from an alphabetical list of seventh graders, that one would be unbiased because it represents the whole population. You're getting a good number. You're selecting randomly, and it's a large enough sample to provide accurate data. So the fact that it's every fifth and you're looking at all the seventh graders, you're getting a good amount of people, and it is random. All right, and following directions you were given in class.